talk about doubly linked lists. We've been using singly linked lists where we have an object. And I better draw that better, I think. Have an object, has a pointer to the first node. Using my mouse today, I don't have my pen with me. Last node, an account. Okay, and we've got these nodes, and they point forward from one node to the next. And as long as you're working here on the front, it's not too bad. But if you're working way over here on the end, and you want to delete, say, the last one, you could have to iterate down the entire list. So one of the ways to take care of this is to do a doubly linked list, where we have one more pointer, and that pointer points the other way. So we can either go up the list or down the list, to the left or to the right, next, previous, something like that, okay? We're also going to introduce shared pointers. Shared pointers are a little bit different than raw pointers. We've been using raw pointers up to this point. Shared pointers take care of a lot of it takes care of the deleting and the initialization better than raw pointers do. It does come at a cost of a little bit of speed because there is that overhead, but they're often easier to use. So let's go ahead and get started. We're going to go ahead and create the node structure. We're going to create this first, and then once that's done, we'll go ahead and create the object. Okay. So beginning the program, I'm going to need to include IO stream. I'm also going to need to include memory. All right, and we will be using std. I'm going to go ahead and copy that. Using cout. Going to be using cin. Going to be using handle. We'll get it. We're going to be using make shared. And we're going to be using shared pointer. All right. Let's go ahead and create the node. And I'm not going to do a class. I'm going to do a structure here, but I am going to template it. So template. This is a struct. Name node. I like to open my body down below. This is a structure, so we do need a semicolon. And in our structure, we need to create these things. We need to create data. Right here, we need to create a place for our data. We need to create a place for the previous pointer to the pointer to the previous node, and a pointer to the next node. So those are the things we're going to create right now. Okay, let's see here. Let's begin with data type. We're going to do the data. Data type T, so whatever is passed in will be created. We're going to do this open and close brackets, which is going to automatically create the, it's all automatically when it creates the node, it's going to default the data in there to nothing. Next, we're going to use shared pointer. Make sure I spell it right. And Actually, I'm going to show you what we did, how a raw pointer would look and the difference. So this is a node for a raw pointer. This is how we would have done that. Done a pointer to next. And the way we're actually going to do it here is with a shared pointer. And next, right? Copy that. We're going to do 2 of those. I'm going to do previous also. Okay, and I've got some errors going on. First off, this is how we would have done the raw pointer. This is how we're doing the shared pointers. So I'm going to go ahead and get rid of my raw pointer there, and then let's see what I've done wrong here. Template. Did I spell that right? Oh, this shouldn't be template. This should be type name. Okay. And then I spelt these wrong. TR, TR, and TR. Okay. So that's our structure for our node. This will create our node when we call it. And we're just creating one of these.